In this demo, you're going to learn how you can create a server-side REST API written in the Swift programming language. You start with an OpenAPI Swagger definition, you generate the Swift server-side code, and then you deploy it to a serverless runtime environment called AWS Lambda. I'm Sebastian Stormack, I'm a developer advocate at AWS, and I realize there is a lot of different concepts in this demo. So let's try to break these concepts one by one. I just suppose you know about Swift and a bit about OpenAPI Swagger definition, but I'm going to explain the rest. So, what is a serverless first? Typically, when people ask me about serverless, I tend to answer, hey, this is not that. This is not empty racks into a data center. Serverless means you don't have to manage the server. We take care of that for you. So we install the operating system, the runtime, and we manage the operating system. But not only that, also the scaling. So if you have only one invocation of your code per second, or if you have 1 million invocations per minute, we do take care of the heavy lifting of scaling for you. You don't have to take care of that. That's the premise of a serverless compute in general, and more specifically about serverless function called AWS Lambda. So Lambda is an entirely managed services where you can deploy your code, and we, AWS, take care about all the rest. So you, as a developer, just have to focus on your code. That's exactly what we are going to do in this demo. Lambda function can be invoked by many different ways. It can be programmed in multiple programming language. Typically, AWS customers are programming in Python, in Node.js, JavaScript, Java. Then they compile or they assemble their code in a zip file or in the Docker container image, and they deploy that to Lambda. But how do you invoke a Lambda function? Typically, you put something in front of the Lambda function. If you want to create a REST API, you're probably going to put an API gateway in front of your Lambda function. The API gateway will be the endpoint to terminate the TLS connection, to marshal the parameter, to understand that there is a query parameter, headers, and things like that, package all that as a JSON payload, and invoke your Lambda function. It means that your code will receive a JSON file with the different parameters and description of the request that has been made, and you just have to answer with another JSON file that the REST API gateway will send back to the client. The REST API is only one way to invoke your Lambda functions. You can also invoke your Lambda function with a GraphQL API, or you can invoke a Lambda function when a message arrives in a queue to create some kind of asynchronous communication between your component. You can trigger a Lambda function when there is a change in a database such as DynamoDB, or you can even run your Lambda function on schedule when at regular interval of times, like every 15 minutes, every hour, every night, every week. So let's see how you can deploy a Lambda function. Typically, you have your code in a zip file. It's code compiled for Amazon Linux, and then you use the AWS CLI, AWS Lambda create function. You give your function a name, the path to your zip file, maybe some permission as a role, the type of runtime, and that's the one way to deploy a Lambda function. But remember, most of the time, you need to deploy your Lambda function and something in front of it, like a REST API gateway, for example. So how can you define that infrastructure in an easily and manageable way? Here is SAM. SAM is a serverless application model. So I would like you to introduce my friend Sam on the screen. With SAM, you can write a description of your infrastructure. What are the functions that you need? What type of CPU architecture they need? How much memory do they need? You can also define what are the events that are going to call your function. And that description is a text file that you can version with your project. You can git commit and git push and create a pull request on your infrastructure. This is what we call infrastructure as code. So if we look at that example of the screen, it's a bit small. Let's zoom a bit more. There are two parts. The first part is a creation of a function. You see type AWS serverless function there on the screen. It will run on an ARM64, that's Amazon Graviton CPU. The zip file is mentioned, and any environment variable I want to pass to my Lambda function. And then in the second part, I tell how to invoke that Lambda function. So I create an event, something that will generate events to Lambda. In this case, it's an HTTP API, and that function will only be invoked on HTTP GET method when the API is called on /test. So based on that, I can use the SAM command line to call SAM deploy, and it will create for me this infrastructure, an API gateway configured to call my Lambda function when there is an HTTP GET event on /test. So now you have a basic understanding of what is Lambda and how you can deploy your Lambda function together with some other piece of infrastructure thanks to SAM. Let's see how you can write Lambda function in the Swift programming language. And to do that, I have to introduce you briefly about the concept of a Lambda custom runtime. So remember, Lambda is a function running in the cloud. So we create micro virtual machines for each of your Lambda function, and we scale these automatically depending on the number of requests that you are sending to your Lambda function. So inside a Lambda custom runtime, there is your code, the zip file that you sent, and it might be any type of code written in any programming language, for example, in the Swift programming language. But to be able to bridge the Lambda service to your code, we need what we call a runtime handler. And the runtime handler is a very simple program running inside the Lambda micro VM that will create an infinite loop asking the Lambda service, hey, do you have an event for me to process? It's an HTTP REST API call from your code to the Lambda service saying, hey, give me the next event to process. When there is an event, your Bootstrap program can invoke your handler code, so the code of your Lambda function, your business code, and whatever is returned by the handler code can be sent back to the Lambda services with an HTTP post on /response. So this is the high-level concept of a custom runtime. It can be written in any programming language that is able to run on Linux. I wrote a bash, a Lambda handler, for example, just for a demo. I know that some customers are deploying PHP Lambda handler. I know some customers deploying COBOL Lambda handlers as well. Anything that can be compiled, and of course, Swift can be compiled for Linux as well. So you can write your handler code, that's your Lambda function, and you can write the Bootstrap to interact with the AWS Lambda service. But that's a lot of work, and you don't want to repeat that undifferentiated heavy lifting type of work for every single Lambda function you're going to deploy. So how can we bridge the two a bit more easily? There is an open source project for that. It's the Swift AWS Lambda runtime. So it's an open source implementation of that Bootstrap application that I just described that interacts with the Lambda service, the AWS Lambda service, and invoke your code whenever there is an event to process. So you don't have to take care of that. You just have to add that as a dependency to your Swift project. So how do you write your first Lambda function in Swift then? It's quite easy. First, you start with an executable project. So using the Swift package manager, you create a product executable and a target. From there, you add the two dependencies that you need. One of them is the Swift AWS Lambda runtime. That's the project I just described. It gives you the mechanism to call the AWS Lambda service to receive event, call your handler, take the response from your handler, and pass it back to the AWS Lambda service. The second dependency is Lambda event. Remember that Lambda functions receive a JSON payload, so we need a collection of struct, Swift struct, to actually represent that JSON payload in input and in output. Depending on the type of services, depending on how you're going to invoke your Lambda function with an API gateway, with a queue, with a scheduler as a trigger for database change, the JSON event, the JSON payload will change. And that library, Swift AWS Lambda events, has models struct for the majority of the Lambda payload, at least the one the most typical on AWS. So you add these two dependencies, and then you're ready to write your code. Your code, it's a main struct, meaning that it's a standalone executable that will be run inside the Linux micro VM of the Lambda runtime execution. So you create a struct, you implement the protocol simple Lambda handler, and you import, of course, the Lambda event and the Lambda runtime, and then you have just one function to write. It's the entry point of your code. So that function is going to be called by the Lambda runtime whenever there is an event for you to process. The name of the method is handle. It receives as an input an event, and the context, which gives a bit of information about the runtime itself. It's asynchronous, it might throws, and it returns a response. In this example, the service in front of my Lambda function, so the service that will invoke my Lambda function, is actually an API gateway. So the type of the event, it's an API gateway request, and the response, it's an API gateway response. In there, I can do whatever I want. That's my business logic. In this case, I just collect the headers that I receive as an input, and I send everything back as an output. So that example is just like an echo type of function that sends back everything it receives in terms of parameter, in terms of HTTP header. It's a very simple example for a demo. Okay, now I have my code ready, and I need to package that so that I can deploy it on Lambda. But remember, Lambda is running on Linux. So if you compile this code on your Mac, it will generate a macOS binary, which cannot run on Lambda. So you need to build for Linux. How do we do that? It typically involves Docker, and you need to install Amazon Linux on Docker, and then the Swift toolchain on Docker, and then compile everything. Seems a bit complicated? Yes, it is quite a bit complicated. So inside the Swift runtime, you will also find a Swift plugin that will do that for you. So you just have to call Swift package archive. And this plugin will invoke Docker, will compile your code for Linux, and create a zip file compiled for Linux, ready to be deployed to Lambda. Of course, you need to have Docker installed on your laptop for this to run. One command, Swift package archive. The disable sandbox is there because the communication with the Docker daemon goes through a Unix socket, and that's a type of network communication which is disabled by Swift package by default. So right now we have to disable the sandbox to actually authorize the communication with the Docker daemon. Now you have a zip file. Congrats! How you deploy that? Remember, we have our friends. We have a SAM. So I create a SAM template that points to the zip file that has been created, and I use the SAM deploy command to actually deploy the zip file, but also create additional infrastructure in the cloud for me. In this case, it's the API gateway. One of the things I like with SAM is that I can test locally before deploying. That helps me to speed up my code debug deploy process. So you can invoke your Lambda function inside a Docker container with SAM local invoke. You give the path to your template, and you give the JSON file. Remember the payload that your function will receive at runtime. Then the name of the function. It will generate a lot of outputs, but if you print something to the standard output inside your code, it will be there. So that's a very good basis to start to debug your code. Okay, now you understand the basic of Lambda, SAM, how to write a Lambda function in Swift, and how to deploy that Lambda function written in Swift to AWS Lambda. But in the introduction of that talk, I say, hey, we are going to start with an OpenAPI, a Swagger definition. So a YAML file that describes my API. For this demo, I'm going to use a demo stock quote application. So we are going to create a very simple stock API. So whenever there is an HTTP GET on /stock and then a symbol passed to the API gateway, it will invoke a Lambda function that will return a very small JSON object with a percentage change, a value change, the price of the stock, the symbol, Apple, in this case, timestamp, and the volume exchange that day. So that's typical financial data from the stock market. A couple of months ago, Apple released the Swift OpenAPI generator. So it's an open source project that is available on GitHub, written and maintained by Apple, that allows to start from an OpenAPI definition and generate Swift code. Either it generates the client-side code or the Swift server-side code. So that's super powerful because the code generation includes client and server. It also includes all the types that you define inside your JSON OpenAPI definition, and it's packaged as a Swift plugin. So every time you do Swift build, it will rebuild the code, the Swift code, based on your OpenAPI definition. So it means that your code will be always synchronized with your OpenAPI file, your OpenAPI YAML file. And it's independent from the transport. So the server side or the client side that are generated doesn't know anything about how to expose the server or how to communicate from a client. The transport can be added as a second step. And in this demo, I'm going to use a Lambda transport. So we will expose that server-side OpenAPI Swift service as a Lambda function. So let's start with the OpenAPI Swagger definition. It's a YAML file that defines the different HTTP methods, the different paths, if you want to get, post, the different types of arguments that are received as an input, and the response. So in this example, it's /stocks with symbol for an HTTP GET. The name of the operation ID is get quote. That's the name that will be generated as a function in my Swift code. And look at the parameters. The parameter says it's symbol, so that will be the name of my variable in my code. It's in the path and it's require and it's a string. On the response side, there is a 200 OK response when everything goes well, and the content is a JSON. And the schema is defined in the same file. I'm not going to show you the schema here. It's not relevant for this demo. How do I add that to my project? So I start with a standard executable as well, and I add two dependencies. One of them is the Swift OpenAPI generator, so the plugin that will generate the Swift code for me. And the other one is the Swift OpenAPI runtime, so it's the logic that will invoke that will be invoked at runtime to actually call my function. I create an executable target and I define the plugin as the OpenAPI generator plugin. On the code side, I just have to import OpenAPI runtime. I write a struct, I implement the API protocol, and that protocol has one function for every operation in my OpenAPI Swagger file. So remember, in my Swagger file, I had a get quote operation. So it generates inside the protocol a get quote that takes an input and gives an output. It's asynchronous and might throw. And the input and the output represent the input parameter and the output parameter. This is also generated based on the OpenAPI Swagger definition. To build that, I just, as usual, type Swift build. It will compile everything and generate the code based on the OpenAPI Swagger definition. So, enough talking. Let's show you that live in a real demo. I start with an empty project. You see there is absolutely nothing here. So let's type Swift package init, and I want an executable. So far, so good. I have a hello world main that has been created for me. So if I want to create an OpenAPI Swagger definition, I have to add to my source the OpenAPI YAML, and that's exactly the one I show you on the screen. It has a schema to represent a code, which is an object with symbol, price, change person, number, timestamp. It accepts the path /stocks symbol for HTTP GET, and it takes a symbol parameter on the path, which is required, and it's a string. And the response contains the quote. I also add a very simple configuration file for the generator that says, hey, I want to generate the types, so the quote struct, and the server implementation for that to be able to receive a call as well. The next thing I'm doing, I'm going to implement my quote. So quote service API protocol. API protocol will be generated when I will type Swift build, and that's a dependency that I will add just in a second. In the implementation, I read input path symbol, that's a string, and I generate a random response. So the price is random, the change, everything is random. So don't worry about the price that you're going to see in the example. If you own Amazon or Apple stock quotes, the price I'm going to show you is totally random. And then I return a response saying that everything was okay, and the body is the JSON of the price object that I just created. The last step is about adding my two package here. So my package dependency. So I told you I'm depending on the Swift OpenAPI generator, that's the plugin, and the Swift OpenAPI runtime as well. I have one target called quote services. I add this section to avoid warnings from the compiler saying, hey, these files have nothing to do in the source directory. And I define the plugin. So when I type Swift build, it should download the dependencies, compile everything, and I have a build complete. It works. Oh, it didn't download everything because I didn't save this file. That's why it was so fast. Okay, now it's a bit longer. And it should compile. Yeah, it's compiling. It takes a bit of time because there is a lot of dependencies and everything is downloaded as a source file. So I need to compile these 400 different files. Now the compilation is done. The OpenAPI plugin run. It generates the code for me. It generates the server, the type, and now it's compiling my quote service. And you see that everything is compiled. That's great. I have an OpenAPI server-side implementation of my quote service, but I cannot deploy that. I need to expose some kind of logic to bind a transport. The transport can be any web framework such as Vapor or Hummingbird, or it can be a transport to deploy that on Lambda, and that's what we are going to see in the second part of the demo. It's how to add a transport, and more specifically in this case, a transport to deploy that implementation to AWS Lambda. It's actually quite easy to add a transport, any type of transport. There are just a couple of steps. The first one is to add a couple of dependencies. So here I want to transform my code to be a Lambda function. So I will add the Swift AWS Lambda runtime and Swift AWS Lambda events, just like I did in the previous Hello World type of Lambda demo. And I will also add a dependency on the Swift OpenAPI Lambda. So that's the library that will make the marshalling of the Lambda parameter and calling your OpenAPI implementation. And of course, I add the dependencies in my product as well. On the code side, there are only 4 changes, and they are very easy. So the very first one is to import the OpenAPI Lambda. The second is to tell, hey, this is a main function Remember, Lambda, it's a command line executable, so you need to add the arrobas main annotation. Then we are going to also implement the OpenAPI Lambda HTTP API and add a constructor to register the Lambda transport on this specific implementation. So at runtime, the OpenAPI runtime will actually call that constructor, that init method, initializer, and it will register. This is where it's going to happen, the registration of all the paths that you define in your OpenAPI YAML file and map them to the different functions. So the /stock/symbol path will be mapped to the get quote function. And you might have multiple paths for multiple HTTP verb like get post, mapping to different functions. That mapping will be done inside the register handler part. Once this is done, remember it's a Lambda function now, so I need to compile it for Linux and create the zip file with Swift package archive. And I need a SAM template to create also the HTTP API in front of it. So that SAM template will be very simple. I refer to the quote service.zip file that has been created in the previous step. And look at the bottom part. The API is an HTTP API, but it will proxy any HTTP verb and any path to the Swift code. So by using this, I'm telling the API gateway to not try to understand or to marshal the path and the parameter on the API gateway path. It's whatever is received, give that to the Lambda function, and the Lambda function will take care of the routing, as I explained with the register handler function. There will be a routing from a verb, path, parameter to your specific function implementation. Once it is ready, I just type SAM deploy, and that's it. It gives me an endpoint that I can call. So let's try that in reality. The first thing I want to do, remember, is to tell my code is a Lambda function. So I need to add a couple of dependencies to my package file here. Remember, there are 3 dependencies: the Swift AWS Lambda runtime, the Swift AWS Lambda events, and the OpenAPI Lambda transport. So these are just the package. I need to add the libraries to my target as well. So let's do that here. And now I have these 3 dependencies that have been added as well. That's the first thing. The second thing is to change the quote service .swift. So let's rename that to avoid any conflict with the main method, quote service.swift. And I told you there are only 4 changes. The first one is to import the OpenAPI Lambda. The second is to tell, hey, this is a main, it has a public static void main. The third is to call, to implement, the OpenAPI Lambda HTTP API interface. And the last one is to implement an initializer, so public init. I'll receive a transport, which is of type OpenAPI Lambda transport. This is created by the runtime for me. I don't need to take care of that. And I just tell the OpenAPI runtime to register all the handlers, so all the function in this struct on this transport. So 1, 2, 3, 4. Let's try, if I didn't forget anything, let's try to build this. So by adding the Swift runtime dependencies, I'm adding a lot of dependencies because the Swift runtime is built on Swift NIO, Swift Neo. So I need to to actually download, or the Swift package manager needs to download all these dependencies. Of course, I'm typing live in front of you, so I'm doing tons of stupid mistakes, like putting a dot instead of self-register handler, API protocol, OpenAPI, Lambda, HTTP API, OpenAPI, Lambda, API, it's OpenAPI, Lambda transport, and now it should build. No, oh yes, of course, this can throws. I want to show the reality in my demo. I don't want to make it fake. Okay, now it's building. How am I going to deploy this? So I take a template file, and that one I'm not going to type it in front of you. We are going to see what is in this template file in a second. But first, I want to deploy that. The deployment takes a couple of minutes, and that's why we are going to analyze the template files together during the deployment. To deploy, I need to give the name of my application. Let's call it quote service. The region. Do I want to confirm the change before to deploy? No. Do I authorize creation of permission of roles? Yes. Disable rollback? No. There is no authentication. It's just a demo. Please don't do that in reality. In reality, you need to be sure that only authenticated user can call your API gateway. It's a subject of a different talk, a different video, because it will take half an hour as well to explain you how it works. To do it is quite simple, but explaining and understanding the idea takes a bit more time. So for this demo, I'm going to say, yes, this is okay, but please don't do that except for a demo. Do I want to save all these answers to a configuration file? Yes, that's the name of the configuration file, and that's the name of my environment. I can have multiple environments like development, test. Save argument, and of course there is an error. Oh yes, I forgot to do something. In my code URI, there is the reference of a zip file, but I didn't deploy I didn't compile the zip file. So let's do that. Swift package, disable sandbox archive. So this will actually compile my Lambda function inside a Docker container and download all the dependencies and compile everything to create the zip file. Once I have that, I can type SAM deploy again to actually deploy the code. So while it's doing that, let's start to look at the SAM template here. A SAM template is made of several resources. Here I have only one resource called quote services. The next section is an output. The output is just telling me, hey, this is the API gateway that I created for you, and it gives me the URL of the API gateway. The resource, I give it a name, quote services. I give it a type, so this is what tells my system that it's actually an AWS serverless function. And then each resource has a couple of properties. One of the property is the code URI. So that's the zip file that is currently being built there under build, plugin, Lambda packager, output, and so on. As soon as the compilation will come back from there, we should have the zip file if the compilation is succeeded. There is a timeout. The handler, so what is the code that will actually handle my method? Swift Bootstrap, and the runtime, it's provided, it's an Amazon Linux 2 environment, which is inside my container. The memory size will define how large is the micro VM that will execute that code. It can be much larger, it can be a bit smaller. That influences the price of the runtime as well. The bigger is the container, the more memory it has, the higher is the price per millisecond that you pay. I'm compiling on an M1 Pro laptop here, so the binary that is generated is for Graviton, so it's important to deploy on the Lambda side for Graviton as well. You have to align the compilation to the runtime infrastructure. In this case, it will be an ARM64, so Amazon Graviton. And then I can pass a couple of environment variables like log level, trace, or debug, for example. So the last part is the event, but I will explain you that while we deploy the code. So the zip file has been created. Now it's uploading the zip file and creating everything for us. So what can invoke that Lambda function? It's an HTTP gateway that will work in proxy mode. So for any HTTP method that it will receive on any path, it will call the Lambda function. And remember, it's the Lambda function, the OpenAPI Lambda transport, that will do the routing between a specific verb, HTTP verb, path, parameter, to a specific method on your code. So that very simple template is allowing us to create a CloudFormation stack with a couple of roles and permission. It creates a Lambda function. It creates a Lambda, an API gateway, and it gives us the address of the API gateway. And we can even test that. Let's curl. Remember, there is no authentication, so I can just try it. And of course, if I code it like that, it says there is no OpenAPI handler register for the path / which is correct. Remember, what is my path? It's stocks. And then I can give a quote like Amazon, for example. And if I do that, the code is correctly routed and I receive the answer as a JSON document. And I can try. Remember, it's random value, so don't be afraid if you see a price there that doesn't match what you have in your stock portfolio. That was my second demo. And that's almost the end of this demo. I just want to finish on one more thing. Creating a Lambda function from scratch with Swift package, init, type, executable, and adding everything by hand. It's undifferentiated heavy lifting. So currently we are working on a Visual Studio Code extension. I hope I will be able to demo that very soon in a next video, in a next demo. And that extension will allow you to select a template like a Lambda function plus API gateway, or Lambda function and a queue, or Lambda function and something else. Download that template, customize the template for you, so adding your own project name, for example, and then build and deploy and invoke your project directly from the comfort of your Visual Studio Code deployment. So it's an extension that we are currently building. It will be open source, of course, and I will demo that in the next video. So what did you learn today? You learned about Lambda functions. It's a serverless runtime environment for your code. You learn about SAM. SAM is infrastructure as code. It allows you to describe your infrastructure in a YAML file and deploy to that file to create infrastructure in the cloud for you. And then I show you how you can write a Lambda function in the Swift programming language thanks to the open source runtime for AWS Lambda and the Lambda event library. Then we talk about OpenAPI, starting from an OpenAPI Swagger definition, generate the Swift code for the server side, and then plug that into a Lambda function. So I'm very curious to learn about what you're going to build using this technology. Thank you for watching this demo until the end. You can reach me on most social network, LinkedIn. You have my GitHub with this demo and a lot of other code in Swift as well. YouTube, X, and all the other. Thank you for watching, and see you soon.